Good evening. It is October 26th, and we're getting close to, well, it's pretty close to winter time. We had some snow this morning. It was about an inch outside and inch on the panels. I had to go out there and brush it off, and you know, that's just normal stuff if you're going to be off-grid in the northern states. This is all the stuff that most people that watch videos concerning off-grid power systems are familiar with. You know, you can, without me pointing it out, you can figure out most of it. Charge controller, inverter, you know, obviously that's some kind of switch box. That's what sends power to the house. We got our battery bank. Those are the main components. Everybody knows what those are. This is kind of a little bit more complex system than a lot, but some of the other ones are also pretty familiarable. We got our dump load controller for the wind turbine setup. 2 rectifiers, 100 amp rectifiers. Lots of yous have those. There's a 300 watt or 300 amp, rectifier on a big old heat sink with a fan behind it. That's for my generator. You know, resistors for the wind turbines, all our meters, you know. Being able to measure and record everything is important. This one meters my total output and accumulated power from the turbines. This was reset, I don't know, earlier this summer. And no, that's not a lot. The leaves only just fell off, so they'll finally get to work. These ones measure watt output and then peaks on the 2 different turbines. We got the 500 and the 800. My switching system for high wind speed braking. Got a completely different video on that if you're interested. Check it out. Don't use brakes on your turbine. There's better ways to do it. This video is about the little things. You know, yep, that's an inverter. That's you all know what that stuff is. This another meter. This monitors what goes into the inverter. That's this shunt right here. So that's the amps and voltage going into the inverter. This one measures what's coming out of the inverter here. Damn glare. So that way I can calculate my efficiency. So right here I've got 1112 kilowatt hours used, 915 kWh used coming out. It took that much energy to produce that. So yeah, do the math and you can figure out the efficiency rate. My inverter is about 85. It's not bad. It's not awesome. It does make solid power. Its peak is actually 6,000. I've had it up there. But again, it's not what this video is about. It's about the little things. Right here, we got a step-down converter, 24 volt to 12 volt. I've got 24 volt bank, 10 batteries. It's actually 5 batteries because each series essentially is 1 battery. So I've got 5 24 volt batteries. Accumulates 550 amp hours. And to run my 12 volt DC loads through the house, I've got various fans, phone chargers, even a ceiling fan, a couple odd things upstairs, and some workshop lights. That's all distributed right here, and this produces the 12 volt. So, quick example of 12 volt loads. Fog lights also make excellent workshop lights. And then I also ran myself down two 12-volt sockets, so I got a little, car vacuum that I can clean up my table. And I can plug a phone charger in there, and I don't have to plug it into the wall. Over here, I've got my hot water system. This is a 12-volt water pump, and that is operated by temperature sensor. The sensor probe is on the chimney pipe over there. That kicks the pump on and off basically when there's a fire going. So it's not circulating water through the copper coil when the fire is not going, because just as the copper coil will heat it up, it will cool it down when the fire goes out, and the warm chimney that continues to draft and pull air through it will begin to pull cold air. So it kicks the pump off, stops circulating water, and then the hot water that's in the tank just stays hot until the next time I either use it or start another fire, and then she kicks on. But again, that's 12 volt. This line coming right here runs to all my circulation fans. Instead of using the big squirrel cage fan, which is like an 800 watt fan built into my furnace, gas furnace, this is my backup system. I hate this old pig. That's my backup system. That takes about 1200 watts to run. I hate having to run this. But, whatever. It's there in case, I don't know, I break my spine and I can't stoke the fire. I've got a wood furnace. This costs me nothing to run. I harvest all my wood for free. And instead of using, again, that huge fan in there to push this hot air into the house, there's individual 12 volt 200 millimeter computer fans that circulate the air into the upstairs. One of these guys. They're awesome. They're silent, and they move a lot of air, and they glow blue. Let's go check them out. Alright. We're upstairs in the living room. I should have brought my infrared with me. I could have measured that. It's probably about 105, maybe 110 degree air coming out of there. And that just blows slow and steady. Here, I'll shut up so you can listen. It's such a quiet hum. You don't even notice there. Way quieter than a big furnace squirrel cage. And then here's the bedrooms. Another one in there. Another one in there. And this is a different style, but same fan. And then while we're up here, I also got this guy. That's what the heck was this? I think they're 20. It's about 24-inch diameter, I want to say. And I've got another 12-volt power port up here, just like your cigarette outlet sockets. Phone charger, and then this just monitors battery voltage, and then I can push that guy in, and you'd be amazed how much air that moves. It's kind of noisy, whatever. It was $15 on Amazon, and on a hot day that sound doesn't bother you. So while I was up here, I thought I'd just show you. 74 inside, 32 outside. It's downright balmy in here. And here's one more. This is switched to another 200 millimeter fan. This one doesn't light up, but it's a nice, quiet, gentle breeze above the wife and I's bed. It's not beautiful, but it's quiet and it uses nothing for power. That's like 1.5 watts. And then right below it, hard to see, lighting could be better. That's the kill switch for the inverter. And let's see, is there any more? Nope. 12 volt loads over there. So yeah, to be off grid, especially in the northern states, yep, you gotta have your big parts. But if you really want to stretch your power out and you want to stay warm, if you've got, you know, anything bigger than a damn tiny house to try and keep warm, you're gonna have to move that warm air around. You're gonna end up having to heat with wood, and you're gonna have to find an efficient way to move that air around, and just, you know, shop around. Computer fans are cheap, and the bigger ones are silent. The big 200 mils, and even the, what do I got here? I think these are 120 mils that I got behind my rectifiers, and those are pretty damn quiet also. They're on temperature switches, so I can't just click them on, otherwise I would. There's other videos with those running, but they're silent. But it's the little stuff. It's your DC loads, and, you know, gauge your wire properly depending on what you plan on running. You know, the one going to my workshop, I got 12 gauge. The ones going to 1 watt fans and stuff like that, I've got smaller gauge. Yeah, it's a speaker wire, but it's all one complete length, and it's I actually looked up what amperage I should use with each load, and then, you know, set up these nice little bus bars. I can kind of show you that a little better. But, you know, it's on insulated ring connectors, you know, and you will end up having quite a few of these little loads. The more clever you start getting, you think all kinds of things. There's DC TVs, there's DC fridges. The more you can run without having to run your inverter, you'll save. Because, like we just figured out, that's 85% efficient. So that means 15% of the power that goes into that is just gone. It's just gone in inversion. But that my circulation system, instead of using, you know, 750 watts just to move air upstairs, I'm using 5 fans, 2 watts piece, 10 watts to pull it up. And my water pump is using another 4 watts. So I'm using, you know, 14, let's call it 16, just, you know, be liberal about it. 16 watts, and I'm heating my water and a 3-bedroom home in Wisconsin in the winter. And it's cozy in here, and my water is probably hotter than yours. I'll bet my water's 137 degrees right now. Let's go take a peek just for fun. Anybody that ever says the copper coil doesn't work doesn't know how to do it. Let's see what we got here. Holy! What did I say? 137? It holds about 140 all winter long. It's a 20-foot copper Coil, 3/8 inch. I got a whole nother video on it. Check it out. It works. But anyhow, the little things. Be clever about being off-grid. There's all kinds of stuff that you can run more efficiently than what you're used to. When I look for appliances, you know, little gadgets and stuff, I look in the car aisle, or you know, stuff that I can plug into a cigarette lighter. So anyways, thanks for watching, and take care.